Hello and welcome. I'm going to have a go at a challenge from the Excel Collegiate Challenge today. This is an interesting one. Excel made an appearance at the CECC, which is like this giant collegiate esports tournament, which is, uh, I don't know, like, I guess, Fortnite and that kind of thing. I don't play a lot of computer games anymore because I'm old, but I play Excel, and apparently that counts now. So Excel made an appearance at this, and the case was called Excel Shuffle by Yeo Tze Sheng. And quick sidebar, I do try to pronounce people's names right, but I've been reading this in my head for, I don't know, as long as I've known the name as Tze Sheng. The internet told me don't pronounce the T. It's just Tze Sheng or possibly Tze Sheng. It's likely I would be pronouncing it wrong anyway, even if I picked the right one because I'd get the tone wrong or something. But I do try. Anyway, also known as Arvi, which is presumably to make it easier for silly Western people like me. All right, so I watched the live match, so I know the basic gist of it, which is we're doing this kind of shuffle on a square. So we're kind of shuffling things to the left and right and up and down, and rotating. Which I looked at it and thought it was like a Rubik's cube thing. It's not quite that, but it's something kind of like that. So I always like to kind of give full disclosure um, when I'm about to do my first attempt, but not really a live attempt, and definitely an easier setup than the people who had to do it live on the day. But anyway, having said that, I'm still going to time it just for lols, and let's get started. Welcome to Excel Shuffle, a fun game where participants have to shuffle some cells to become an Excel Shuffle master. The face and wings of the square. The square sheet contains a square shaded in orange. Yep. These cells will be referred to as the face. The face is bounded by 5 cells shaded in gray on either side, which will be referred to as the wings. Okay, so we got a wing on the top, bottom, left, and right. Horizontal and vertical moves. In each game, you'll be provided with a set of instructions or moves to shuffle the faces, denoted row, column, magnitude, direction. For example, x3 left means to shift the numbers in the row labeled x in the square by 3 moves to the left. Any numbers that fall out of the gray area will be recycled and start from the other end. See visualization. So if we shift 3 to the left, okay, all these green ones shift over and these blue ones go to the end. That makes sense to me. On the other hand, the notation A3 down means the values of 1, 6, and 2 being moved into the orange face. Yes, so these ones move down into the face, that moves at the bottom. These ones move to the top. Do we have? No, we don't have a visualization. Anyway, I got the idea. Okay. All games are independent of one another and moves are to be applied to the starting square at the, okay, so this is the square all the time. So let's get some labels. I'm going to call this squa. I'm going to call this, I guess, C lab for column label, and I'll call this R lab for row label. Boom. In a set of instructions, move will be separated by commas. For example, means to shovel this, then this, then. Yep, okay. Rotation moves in level 5 onward, directions denoted by swirl and anti-swirl, I guess, are introduced. These refer to rotating the face counterclockwise and clockwise respectively and are notated together with a magnitude to show how many steps to take. Rotation moves only affect the face of the square and leave the wings unchanged. For a detailed example. Okay. So I guess this should end up going down here if we rotate. Oh no. Oh, interesting. Ah, okay. So this is shifting by 1. This is shifting by 1. So the middle stays the same, but everything else shifts around. So it doesn't rotate 90 degrees. It rotates 1 shift. Okay. So then 415 becomes 415. Yes. Okay. Weird, but I get it. All right. Let's dive on in. What is the sum of the 9 numbers in the face after applying the move? Okay. So the way I'm going to think about this is, first I'm just going to concat these together because I think that's how they appear later when they're split up. So what I want is to have a lambda, which I will write, that is going to take my starting square and we'll take some square and some move and apply that move. So let's do this. Let's say, start with this one. so do I need my, I don't know. Anyway, so we'll take the left of that is the one that we're going to apply it to. Mid, I don't know, do we ever have 2-digit shifts? Let's allow for it, I guess. So let's do, well, right of that is the arrow. And then I guess 2 of my arrows are going to be negative shifts and 2 positives. So we'll make that -1, 1, 1, -1. And I don't know, one of these has to be a minus, the other has to be a plus. So I'll call this R, and I'll call this dir. So let's XLOOKUP this in R returning from dir, and then multiply that by mid of this from 2 len of this -2, just in case there are 2-digit things. Okay, so then I want to say, so my general idea here is I'm going to say index on square by sequence rows of square, sequence columns of square. That should just, sequence comma columns, so I want that going across. So that should just give me back, aside from these becoming zeros, that should just give me back the square that I had. So I've got 6724, 6724, yes. And then I want to be able to offset one of these and then apply a mod. So first thing I'm going to do is I'm going to say mod this. I'm going to say this sequence start at 0, mod that by, and I guess the sizes are constant, so I can just, yeah, let's just go with the constants, 13, mod that by 13 and add 1 back. And then same thing here, we'll say mod sequence, comma, 13, 0 by 13 plus 1. And that still echoes back the original grid. And so now I should be able to just apply an offset here. So let's say, let's see, this is my row number. So I want to change my column number for the X. So let's say plus, well, let's say plus that first. So shifting left. Okay, so we got the sign wrong here. All right, so let's just flip all the signs of these. That's going to be 1, -1, -1, 1. Now we shift 1 to the left and we get 7, 2, 4, 3. That's good. But I don't want to shift everything. I just want to shift if my RLab, yes, is equal to this, then that. So now I'm shifting only that one. Yep, that works. And then I just need to do basically the same thing here to say if my CLab, oops, if my CLab is equal to that, then I want to shift that column. So let's just test if I did an A, and technically I should change that to an up arrow, but it should work the same anyway. We got now, let's see, 7162, yes. So let's just take an up arrow just to make sure that I have it calibrated right. 7162. Okay, that's working fine. So now I just want to kind of carve up the different pieces of this. So I'm going to say lambda of start square and dir, and it's going to be let, I guess we'll call it axis, be left of dir, and let magnitude be XLOOKUP right of dir in R returning, oh wait, didn't I call that named range dir? I did, shoot. Call it mauve then. Right, oh, and I always forget to close the right. In R returning from dir. Good. Times mid of mauve by 2 by len of mauve -2. I gotta pause for a second. Okay, sorry about that. I think we were about done. Yes, so that closed the mid, comma. Then the index is the next thing. And then I just need to rename these, so not R1 but axis, and not S1 but mag. And same thing here, not R1 but axis, and not S1 but mag. close the let, close the lambda, and let's give it square and this. And that seems to work fine. Okay, so now let's use my handy robot command, save lambda as. And we'll call it shift, I guess. Okay. Oh yeah, and then the other thing is, the question actually asked about what is the sum of the 9 numbers in the face. So let's just do another very quick one, which will be lambda, equals lambda of squa, just to distinguish it from the name range, and it'll be sum of rlab not equal to blank times clab not equal to blank times squa. And that'll give the sum of the stuff in the middle. And we'll save that lambda as well. And we'll call that midsum. Midsummer Night's Dream. All right. So now hopefully we're spent a long time setting up, so we better be ready to go. So now let's do, what the heck did I call it? Shift from squa by this, and then midsum that. And I think it said 40. Yep, still says 40. That's good. Okay, and then we've got hints. 34 is in there. 28 is in there. 32 is in there. Happy days. Okay, now we got multiple moves, which should be fine. So let's first we're going to want to do reduce square text split of this by a comma. So we'll just apply this to each one, and the function will apply as shift, and then we'll midsum that, and hopefully that'll give us 37. Oh, it gave us 40. Oh dear. Damn. Okay, so let's come over here, and let's take these 3 things, and let's text split that by a comma, and then let's shift square. Oh, hang on. This is highlighting square, which is bad, which might mean I've referred to square somewhere in the name. So let's go into the definition of shift, edit lambda. Yes, okay, sorry. So it should be start square, not square. Okay, so maybe that's all then. Save lambda. See if that fixes it. That now, oh no, that's, all right, so let's try again. Sorry, midsum of shift, sorry, not shift, of reduce square by text split, text split of this on a comma, and function is shift, and that does give 37. Okay, good. And then we got 33 is among the hints, 35 is among the hints, 40 is among the hints. Okay, so I feel a little better about that now. Okay, so then this one should just be a repeat of this one. 36 and 30. Oh, sorry, I need to put in the concat as well. Could have just put that in the formula, but never mind. All right, so back up to here. So 36, 35, that's good. And then these 41, 30, 37, 41, 30, 37. Yes, those are all among the hints. So happy days. And then we'll take this one again. For I think level 4 is just, yes, sequence of moves again. So 38, 38, 31, 51, 38, 31, 51. Yes, seems to be working. All right, rotation. Okay, so after applying the move, what is the number in the top left cell of the face? And then 6 is also what is the number in the top left cell of the face. So this is an interesting one. To do level 7, where you both shuffle and rotate, I will have to implement a full shuffle, but I think I can do levels 5 and 6 relatively quickly without that. So let's just test this. So let's text split this by comma, then whatever, let A be that, mag be left A by len A minus 1. Yes, and then times XLOOKUP right of A in dir, in R, returning from dir. Just do that then. So I've got a 1, an 8, and a minus 12. That makes sense. So then I think I just want to sum these, because we're just doing a certain number of shifts this way, a certain number of shifts that way. The order doesn't matter. How many we do in either direction doesn't matter. It just matters the total cumulative sum. So let's just see if that means we're net shifting 3 more clockwise, which means 1, 2, 3. Yeah, that gets you the 8. Okay. So then I think for this level, it's just a case of, I think I've got the direction wrong in these ones as well, for intuitive sake. I think that should be 1 and that should be minus 1. Clockwise is positive. Anyway, sorry. So here, I'm moving 3 that way, so this is the one that's coming in. So I think I just want to say, this is if there's 0 shift, this is if there's 1, 2, 3, 4, 5, 6, and 7. Okay, so then I've got, what's going on here? I've got this. I guess I want to take this mod 8 so that it is a value between 0 and 7. And then I guess I can make it a lookup table for the sake of niceties. So we'll call this, and we'll call this. And I'll just call this, okay, yeah, so I need to make that not be 0. And I've got these the wrong way around. So then I can do this, call this rot LU, rotation lookup. So this should just be a case of you look up all this stuff in rot LU to 0. And let's see, we should have 1, 4, or 5, and 3 or 8. Yeah, I think that's working fine. And then we should be able to do the same thing up here. An answer, oops. An answer of 5, yes. And hints here, 2, 8, 3. Kind of hard to tell from the hints because there's only so many answers it could be, but I think that's working. All right, so that's that, but then we're going to need to actually implement the rotation to get out level 7. So what is a better logic for the rotation? I still want it to be an operation that takes the whole square and returns the whole square. But no harm in having some kind of mask to say, okay, for the purposes of my rotation, these are all things that don't move, and then this will be is positive, so that's a shift of 1. So I don't know, let's just say for now 3, 4, 5, 6, 7, and 8. So how would you do this? To call of that, and then to call of squa, just as a starting point. So then I guess you'd say if this equals 0, then we keep this the same. Otherwise, we x lookup mod this plus some shift, let's say 1 for now, by 8 plus 1. We need minus 1, let's see. Yeah, all right, well, we'll calibrate in a second, but let's go with that, look up that, and that, returning from this. Where did I get wrong? Oh, yeah, sorry, just close the F, fine. And then let's wrap that in 13s, and we can see what we get back. Wrap rows of this by 13, and let's just take the format as well, be easier to see. Oh, hang on, have I overlapped? No, I've just barely not overlapped that. Okay, so we started with, 415, 192, 283, and now we've got, okay, so yeah, I have done 1 too many, so that should just be mod that 8. Or I guess it should be mod whatever the offset is, -1. And then that shifts it by 1. So then let's just say +5 -1. That should be a shift of 5. So the 4 started off there. And it should shift. Am I going in the wrong direction? I think I'm going in the wrong direction. So what did I say? I said clockwise was plus, right? Clockwise is plus. So if I shift by 1, yes, that's anti-clockwise. So okay, then let's say minus the shift, -1. So now a shift of 1 is clockwise by 1. Okay, cool. So then I've got that. So let A be to call of that. Oops. Well, let's call that flat be to call of that. And I want this to just have some name. So let's give it some name, I guess. I'll call it the rotref, rotating reference. So then we're going to say if rotref is 0, then give me back flat. Otherwise, xlookup rotref minus off, and whatever, let's just say let off be 1 for now. Minus off, and xlookup that in rotref, returning from flat. And then wrap rows of that by 13. Okay, and then this all has to get out of the way, and formatting is now in completely the wrong place, but never mind. That means the square is here. So the 415 is shifted around by 1, so that's perfect. Okay, so then I just need to turn that into a lambda. So it's going to be lambda, start square, and rot. Actually, no, let's make our offset be in the right format as well. Gosh, it's taking me a long time. Never mind. I think I'm getting it basically right anyway. So let's have it be in this format. So lambda of start square and off. Let shift, I guess, be left of off, len of off -1 times xlookup right of off in our returning from dir. Then let flat be to call start square. Rotref. So that will save lambda as, and we'll call it rotate. And then I guess the only challenge is we need one function that does both rotation and shift. So let's text split this by comma. So we can say shift from square by that. That's fine. But if we say shift from square by this, I was hoping that might error out, but in fact it doesn't. Okay, so let's do rotate from square by that. Oh, that's erroring. It's not good. What have I done wrong? Oops, sorry, wrong button. Damn. Edit lambda. Oh, sorry, yeah, because I'm mixing up shift and off. So I gotta use shift, not off. Is that it? I think that's it. Save lambda. So now we're rotating to anti-clockwise, and we're starting from, well, we're starting from the same square, 415 there. So we're getting 415 here, which is good. then hopefully if I want to say that this should not work, but no, okay, good. It doesn't. All right, so then I think I have a basis. I can say lambda start square and mauve, and we're going to say let r let rot be rotate start square mauve, and then we're going to say if or is error rot, then shift square, sorry, not square, start square, gotta be careful with that, mauve, otherwise rot. Not the most efficient way to do it, but it'll do, I think. So then I can save lambda as, call it rot shift. Great name. So then I think I should be able to, now what are we asking for, the sum of the middle squares? Yes. So we should be able to reduce, starting from square, text split this by comma, and apply rot shift at each step, and then we want to take the midsum of that. 36, hooray. Okay, so then do we match the hints? 36, yes. 41, yes. 26, yes. Okay, hooray. So I think that's the levels done, and I suppose just for completeness, we should be able to say equals, so we're interested in the top left square, which is index 66. So equals index rotate SQ by that by 66. I just want to make sure these are all the same. And they are, and do the same, not here, wait, where does it go? Here. We'll do index reduce square text split this by comma, and apply rotate, and again 66 should match the same value. No, it does. Okay. All right. Let's take a quick look at the bonuses. Kind of out of time. Between the numbers 1 to 9, which number is found the most across row X and column A, including the wings? Okay. Blah, blah, blah. I guess I can clear out all this mess. No, I can't because I need that. Never mind. All right. So sequence 10 starting from 0 equals countifs. This is this plus countifs. This is this. I guess I need to subtract off minus this equals 4, because that's the intersection, and we'll get double counted. And of course, okay, so what was the question? Which number is found the most? So the max is 5, and it is 2. For levels 1 to 4, how many times did the direction that was used the least often appear? Okay, excluding examples. All right, so let's v-stack this with this with this with this. And I suppose we should be able to just concat all of that into one. It's not that long. And then we want to figure out for each of the 4 arrows, because we don't have rotations yet at this point. So equals len of this minus len of substitute of this with this by blank. Okay, and we want the one that's used the least often, I think. How many times the right? Okay, so it's just the min of those, which is 39, I think. Yes. Okay. For levels 1 to 4, how many times did the number 8 appear in the final faces after applying the sequence of moves, excluding examples? Will contribute more than once. Okay, so I just want to know how many 8s. All right, so equals sum. Okay, hang on. So first we want to reduce square by text split this by comma, and shift. Then we want to know the number of 8s in the middle, so it's going to be that equals 8 times CLab not equal to blank times RLab not equal to blank. It's going to be the sum of all of those, except we don't want to include the examples. So that works there. It won't quite work here, but let's just point it over there. And works again here, except, nope, all right. Bring it back to here. And then we can take this version down to here. Okay, so the sum is 64. All right, if exactly 2 moves can be taken each shift by 1 unit, what is the highest sum of the, what is the sum of all the shuffle values for the moves given in levels 1 to 7, excluding examples? Oh boy. All right, so, all right, well, I'm not going to get either of these done within the 30 minutes, so I guess I'll take my time and do them both right. If exactly 2 moves can be taken each shift by 1 unit, what is the highest sum of values in the face that can be obtained? So, can I clear some space here somewhere? Let's just do this. So if we shift this way, we'll shift in one of these and shift out one of these. So the gain would be this minus this. What? Oh, why did that one go down? I didn't mean to do that. Okay. Similarly, we can shift and gain this minus this, which doesn't actually gain as much. This minus this also doesn't gain as much, and this minus this. So it looks like the 2 biggest are 5 and 6. So probably the answer is we can add 11. So highest sum of values, so it's going to be the sum of the current, middle values plus sum of these and those. That's my probably answer. But let's see. I guess there's no reason to use a rotate, because even if, like say here, if you could rotate to line the 1 up to go out when the 9 comes in, that would give you a bigger yield, but the biggest yield you could have on any one shift with a rotation is 8, and we've already got 11, so you can't beat that. The only other thing, you could have things interacting with each other. So I think to be safe, I'm going to just lay out all the possible moves. So all the possible moves are X, Y, Z, and 1 and 2 row of what X, Y, Z can move. They're not even next to each other. Okay, fine. And H stack. That and that. And we can call all of that. And similarly, we can call ABC and 1 and V stack, the up, and the down. Yeah, close. Okay. So then we want all combinations of any 2 of those. So we're going to say equals to call this and comma and 2 row of this. So these are all the combinations of 2 moves, and we want to maximize the sum of this. So we're going to midsum of reduce square text split this by comma and apply shift. And sure enough, the max of those is 46. So all the extra work didn't gain much. All right, and finally, what is the sum of all the shuffle values? Oh yeah, okay. So let's start by just concat of, okay, fine. So we'll just do these with commas. All of these. I don't Yeah, I don't need to worry about commas there. These with commas. All of these. All of these, and all of these. Oh, sorry, no, not done. And all of these. So the basic idea here is we want to split out the numbers here. So a nice trick that I know for this is if we first text split this on all numbers, meaning sequence 10 starting from 0, split it on all digits and ignore empties. And actually, let's split it down a column. And we can unique that just so that we can look at it more clearly. These are all the things that split up numbers. So there's comma, comma and a letter, various different letters. There's arrow, comma, letter, blah, blah, blah. There's rotation, all these things. These are all the things that split up groups of numbers. And so if we text split the same original string on that list of delimiters, and again, ignore empties, what we get back is exactly the numbers. And if we go down toward the bottom where there are 2-digit numbers, we'll see those do come out together. So then we just want to minus minus to convert those two numbers and sum. So 1, 5, 2, 3. I don't actually have the answers to this case, so especially for the bonuses, I'm kind of flying blind, but those feel directionally right. Obviously, I didn't get it finished within the 30 minutes. But so what I think I could have got, if I get things right, I think I could have got 1120, and then would not have got these on time. That was a super fun case. It did make me think, like I said, when I saw it, that it was going to be a Rubik's Cube case, which now makes me think we need a Rubik's Cube case. So just going to put that out there. Perhaps I'll write one. Perhaps somebody else will. Perhaps somebody already has. Just going to leave that floating out there. That's all I got for today. Thanks for watching. See you next time.